One of the most mesmerizing events in the cosmos may soon unfold. The potential supernova of Betelgeuse, located at the prominent shoulder of the Orion constellation. Betelgeuse is a red supergiant nearing the end of its life. In a startling event in 2019, this once brilliantly luminous star began to dim, noticeably so to the naked eye. Over several months, its brightness faded dramatically, sparking global speculation about whether the star was on the brink of death. Astronomers quickly turned their telescopes toward the star and were astonished by the compelling evidence of its significant dimming. Betelgeuse is widely believed to be in the final stages before erupting in a colossal supernova, an explosive end to its stellar journey. But the exact timing and cause of this cosmic detonation remain uncertain. Could it happen tomorrow or thousands of years from now? And would such an explosion have any dangerous consequences for Earth? Positioned on Orion's upper right shoulder, the glowing red star, also known by its official name Alpha Orionis, is the second brightest star in the Orion constellation after the blue supergiant Rigel. Though not the most luminous, Betelgeuse continues to fascinate scientists with its peculiar variability and its sheer scale. Alpha stars are usually the brightest in their constellations, but Betelgeuse, despite being outshone by Rigel, captures attention with its deep crimson hue and remarkable size. Betelgeuse ranks among the most famous stars in the night sky. It is the 10th brightest star overall, and the 7th most visible from much of North America and Europe. Its name, derived from Arabic, means armpit of the giant, referencing its placement in Orion. Betelgeuse loses about one solar mass every 10,000 years, ejecting matter in all directions and forming a nebula around it. This surrounding cloud spans approximately 30 astronomical units, 30 times the distance from Earth to the Sun, and is 250 times more massive than Betelgeuse itself. At its core, the star fuses hydrogen atoms under immense pressure to form helium, generating vast amounts of energy. As it exhausts its hydrogen, it shifts to fusing helium and eventually carbon. Once helium is depleted, neon and carbon fusion produce iron. However, iron fusion consumes more energy than it releases, leading the star to collapse under its own gravity, culminating in a dramatic supernova, one of the universe's most powerful explosions. Stars emit light in different wavelengths depending on their age and stage of evolution, ranging from brilliant blue in young stars to deep red in aging giants. Ancient astronomer Tycho Brahe described Betelgeuse's color as ruddy, while early Chinese astronomers saw it as yellow, suggesting that Betelgeuse may have once been a yellow supergiant. Massive stars like Betelgeuse burn through their fuel quickly, living fast and dying young, typically lasting only about 10 million years. While our Sun still is over 5 billion years ahead, Betelgeuse is reaching its final phase. The star undergoes two known brightness cycles, one every 5 years, lasting about 100 days. These changes are likely caused by the expansion and contraction of its outer layers, altering both its size and surface temperature. Interest in Betelgeuse surged during its unexpected dimming in 2019 and early 2020. The sudden drop in brightness, followed by a brief recovery, led scientists to speculate that it might be nearing its final transformation. Despite observations dating back to the 1st century BCE, the reason behind Betelgeuse's dimming remains unresolved. The star is currently hurtling through space at roughly 30 kilometers per second, having been ejected from its birthplace in the Orion OB-1 stellar association, which includes the famous stars of Orion's belt. This rapid movement has produced a bow shock that stretches over 4 light years. Accurately measuring red supergiant stars like Betelgeuse is notoriously difficult due to their variable nature and the interference of surrounding material. Its pulsating behavior further complicates precise measurements, but it is exactly this mystery that continues to captivate astronomers and skywatchers alike. Betelgeuse's fluctuating size is a well-documented trait, and when combined with the dimming of its outer layers, it causes noticeable shifts in both the star's apparent color and brightness, especially the farther one looks from its core. The material that Betelgeuse ejects also plays a critical role in both emitting and absorbing light, further influencing how we perceive its luminosity. Observing Betelgeuse is particularly challenging because its apparent size changes depending on the wavelength used. In fact, measurements of its diameter can vary by as much as 35%, depending on which part of the electromagnetic spectrum is observed. In July 2009, the European Southern Observatory released images captured by the Very Large Telescope, VLT, interferometer, revealing a vast plume of gas extending up to 30 astronomical units from the star's surface, roughly the distance between the Sun and Neptune. This was just one of at least 6 massive outflows recorded around Betelgeuse. Such events may offer crucial clues to how massive stars shed material in their final stages, an essential process in their eventual collapse. Yet, many mysteries persist about how red supergiants like Betelgeuse lose mass and what mechanisms drive these enormous ejections. These stars are fundamental to the galactic recycling of elements, and thanks to advancements in interferometry, astronomers are making strides in solving these long-standing cosmic puzzles. In 2019, scientists using the Hubble Space Telescope and other observatories found that Betelgeuse had expelled a significant portion of its outer shell, resulting in a rare and violent surface mass ejection, SME. While our Sun occasionally emits solar material, Betelgeuse's outburst was exponentially greater, releasing approximately 400 billion times the mass of a typical solar flare. This massive expulsion is believed to be the cause behind the star's dramatic dimming in late 2019. By mid-February 2020, Betelgeuse's brightness had plummeted to nearly a third of its usual level, dropping from magnitude 0.5 to 1.7. However, by February 5th, it appeared the dimming had stabilized. Importantly, the observed decline in visible light wasn't linked to an imminent core collapse, as infrared readings remained unchanged as of February 24, 2020. When Betelgeuse eventually explodes as a supernova, it will rank among the most spectacular astronomical events in recorded history. Despite its distance of roughly 640 light-years, the explosion will be so luminous that it could rival the full moon, possibly visible even during the day for several weeks or months. Scientists estimate the blast will release more energy in mere seconds than our Sun will generate over an entire 10 billion-year lifespan. The resulting light will speed across space and appear from Earth as a brilliant, never-before-seen point of light in the sky. But rest assured, despite sounding ominous, Betelgeuse is far enough away that its eventual supernova poses no danger to Earth's biosphere or life. Instead, it promises to be an unprecedented scientific opportunity. In recent years, Betelgeuse has returned to normal brightness levels, though its erratic dimming patterns remain under close observation. Astronomers are employing a range of powerful tools, including the James Webb Space Telescope, JWST, the Hubble Space Telescope, and ground-based arrays like the VLT and ALMA, to monitor fluctuations in surface brightness, convective behavior, and ongoing mass ejections that signal the star's instability. One leading theory suggests that Betelgeuse's dramatic fading was caused by a vast cloud of dust expelled during one of its outbursts, which temporarily obscured its light from Earth's view. Understanding the inner workings of Betelgeuse could help scientists better comprehend the life cycles of massive stars approaching their end, and potentially allow them to predict similar cosmic events in distant galaxies. These insights could also shed light on how stars enrich the universe with heavy elements like carbon, iron, and oxygen, building blocks of planets and life itself. The cosmos tells a story of how elements like iron and gold are forged and scattered across space, and Betelgeuse plays a central role in that narrative. This red supergiant, often described as a ticking cosmic timepiece, is slowly nearing the end of its life. Whether it explodes tomorrow, next year, or 100,000 years from now, its eventual supernova will be both a breathtaking celestial event and a once-in-a-lifetime source of scientific data. Studying the life and death of massive stars like Betelgeuse is far more than academic. It's essential to understanding the universe itself. These giants serve as stellar foundries where heavy elements are created. When they die in powerful supernovae, they eject these elements into the cosmos, enriching nearby interstellar clouds and seeding the formation of new stars, planets, and even life. What makes Betelgeuse's impending supernova so remarkable is its proximity. Most supernovae observed by scientists occur in faraway galaxies, limiting the quality of data we can collect. But Betelgeuse lies within our own Milky Way and is relatively close in astronomical terms. If it explodes, astronomers will be able to study every stage of the event with an unprecedented level of detail. This potential explosion could also yield valuable insights into neutrinos and gravitational waves. A stellar collapse doesn't just emit visible light. It releases a massive burst of neutrinos and may generate measurable distortions in space-time. Instruments like LIGO, Virgo, and IceCube stand ready to detect these signals, offering fresh perspectives on stellar physics and the fundamental forces that govern the cosmos. Scientists are monitoring Betelgeuse not just for its possible demise, but for the lessons it holds about stellar behavior. Red supergiants like Betelgeuse represent one of the most mysterious phases of stellar evolution. Their sheer size, instability, and complexity make them difficult to model accurately. Though new space telescopes and high-resolution spectroscopic tools have advanced our understanding, many questions still remain. Questions that Betelgeuse might soon help answer. For now, Betelgeuse continues to shimmer, pulse, and surprise. Its brightness appears steady at the moment, but astronomers remain vigilant, watching for the slightest change that could herald a supernova. When that moment arrives, whether tomorrow or thousands of years from now, the data captured may transform our understanding of how stars live and die. Until then, Betelgeuse remains both a celestial wonder and a cosmic countdown, captivating the eyes of stargazers and the minds of scientists around the world.